In this video, we'll talk about logarithm and how to use it in statistics. First of all, let's record a common definition of common logarithm. So whenever we can write a number, a number big N as 10 raised to power of the small n, and then we can write this small n as equal to log base 10, the big N. So you can think about the right-hand side as 10 raised to what power equals the big N. The answer based on the first equation is a small n. So that's the result. That's the value for log base 10n. And again, remember, log base 10n just means 10 raised to what power is equal to the big N. And sometimes we can omit the base if there is no ambiguity and simply write as log of. And you probably have learned this in college algebra if I've taken that course, that if you don't write a base by default, the base value is 10. But this is not the only default value people use. In fact, there's another extremely important constant in mathematics called E that we also use as the base for a lot of cases. So the value of E is approximately 2.71828. And why we use this mysterious number is beyond the scope of this course. If you're interested, I encourage you to take calculus, where you can learn much, much more about the beautiful aspects of E. But for now, just keep in mind that this mysterious number E is also commonly used as a base, especially in higher level mathematics. So don't feel surprised if you see this E as the base of some logarithm, or in some cases, is even the default base for logarithms. So here, and one more thing I want to remind you is that this log of A and x is undefined whenever x is less than or equal to 0. Think about that, because this thing, log A x, means a raised to what power is equal to x. When a is positive, positive number raised to any power, positive or negative, is always positive. So it's impossible to get a negative number or 0. So log of 0 is undefined, log of -2 is undefined, and so on. So you don't want to define log of 0 or log of a negative number. And we can, of course, do logarithm in R. And, well, but I want to remind you that this simple command, log of 100, well, you might think, hey, this should give you 2, right? The answer is no, it gives you this strange number 4.60517. And the reason is because in R, the default base is not 10, it's E. So basically, when we do the log of 100 command, we're calculating the base E logarithm, or in other words, it is the log E of 100. And sometimes we write this as ln of 100. That's alternative notation for the base E logarithm. So keep in mind that in R, the default base is E, not 10. You might naturally ask this question, what if I want to do the base 10 logarithm? There are a couple of ways to do it. You can do log 10 of 100. That is one way to specify the base. The answer is 2 as expected. Or you can simply do log of 100, but now you specify base equals 2. That gives you, base actually equals 10. That gives you 2. Or simply log of 100 and then comma 10, and then the second input is interpreted as the base. Even though this is shorter than the previous command, I don't personally recommend it because you can easily forget what this 10 is talking about. But the previous line, base equals 10, is crystal clear. You are taking the logarithm of 100 with base 10. So all these commands, log 10, 100, log 10, log 100 base equals 10, or log 100 comma 10 will give you exactly the same answer, but not log 100 directly, because we'll be doing the natural logarithm there. Now, if you look at the example 3 on page 36, remember that we have some dollar amount as small as 12,000-ish to $2 million. And this is a very, very large range of data. And if you want to create a histogram, it is still theoretically possible, but it's very difficult because of the large range of the data. However, if you take logarithm, if you take the common logarithm, for example, of the data you see here, now 2 million becomes 6.34 and 12,000 becomes 4.09. So you see here, now the range of the data from is reduced to a much smaller amount. So now the data would be 4 point something, 5 point something to up to 6 point something. This is much smaller range, and therefore it's much easy to visualize using histogram and other techniques. And there is one more example illustrating when we should use logarithm and when we should not. If we are computing something is a certain number of times more than another thing, for example, if you want to talk about A's income is 1.5 times that of B and 10 times as much as C, and then we use logarithm. On the other hand, if you want to talk about the difference, not a ratio, such as A's income is $100 greater than B is $300 more than C, then we don't use logarithm. All right, let's quickly recap the key ideas. We'll talk about the tallies and the stem leaf diagrams, make sure you understand how they work. And also we discuss the summary statistics, and including we define Q1, M, and Q3, and IQR, which is Q3 minus Q1. And also we define the two logarithms, common logarithm, that's the base 10 logarithm, and a natural logarithm, that is the base E logarithm. And also we mentioned that how we use the logarithm statistics, and it is mostly used when you have a wide range of data points and you want to reduce this to a much smaller range, and then apply logarithm to make your data into a much smaller range. All right, that's all for today, and thank you very much for listening. I will see you in the next chapter.